I'm going to show you how to run the Mann Whitney U-test, the whole chimichanga. This is a non-parametric test that you're going to use instead of using a t-test. Here's all your data with all the information given. Here's all the scales, etc., etc. Okay, first things first. Step one, get the data ready in your Excel spreadsheet before you transfer it to SPSS. It's just a lot easier to do that in Excel. So I cleaned it up a little bit. So this top row is the names of the variables. You'll notice that I cleaned them up. No blank spaces, no hyphens, no periods, no commas, no nothing. This is the formatting needed for the SPSS naming, okay? So do that with every variable first. This one is what we're going to put in the labels, which defines what the variable actually is. So we're ready to go. So what you're going to do is you're going to highlight all the data, just the numbers, and you can't see that I'm going off screen, but you get a lot of numbers. You're going to highlight all the data. You're going to right click. You're going to copy. You're going to open up SPSS. You're going to make sure you're in data view, right? Data, that's where the numbers go. Go to cell A1, right click, and you're going to paste. And it's going to take a while, but there it is. So now we're going to do the variable names. Okay, we're going to click the variable view. Let me show you a trick here. We're going to highlight all the data, names. Okay, it's going to look like this. And you're going to copy. I'm going to open up just a worksheet. That's what I call them down here. You pick any cell and you right click. You're going to paste with a transpose. See that little guy right there, the transpose? That turns them into a column. And then copy again. Go back to the SPSS sheet. Highlight everybody. And then right click, paste. And if there's no mistakes, it does it nice and perfect. So there's all the names. There's the variable names. We're going to do the same thing for the explanations. These are what they call labels in SPSS. Let's get all those. And same thing, you're going to right-click, copy. And go back to the worksheet and pick cell, any cell, right-click, paste, transpose. And you're going to paste them right into the label right there. So you have the names of the variables. You have what I call the descriptions of the variables. Those are the labels. These are what's going to show up in the output for SPSS. Now, we only have a couple of categorical variables. The first one is relationship. We mark it as nominal. The second one is group. We mark it as nominal. But now if it's a nominal, you've got to identify what the numbers mean. So back up to relationship. There they are. And the only one we're looking at is priest or clergy is number 7, and everybody else is going to be the other. So that's what we did with group. 1 means they were perpetrated by clergy. 2 means they're non-clergy perpetrators. Okay, so that's what we did. We turned the relationship variable into a dichotomous categorical variable. Okay, so now we're ready to go with everything. Step 3, you need to check the t-test assumptions. Because you're comparing two independent groups, right, clergy versus non-clergy, and all your scales are the DVs, so we need to check the assumptions about the DVs, and I hope you remember those, but they are normality. The short definition is most of the data has to be around the mean. That's a short definition for normality. Independence of observation or independence of sampling. There's no way to test that, so we just assume it was not violated. The last one is homogeneity variance. In other words, the variance of the data for the clergy should be relatively the same as the variance for the people that were not clergy. That's homogeneity variance. So we're going to run those 3 tests in SPSS. Let's go back to SPSS. Where are you? There you are. Okay. First thing I'm going to do is check normality for all of your DVs. We're going to go to Analyze, Descriptives, Explore. We're going to use one of the tests that SPSS offers to check all that stuff for. So we're going to kick in all our scales. We're going to go to plots. We really don't need the histogram. Histograms can be misleading, especially with a smaller sample sizes, and that's kind of what we're dealing with. But this is your main thing. You want normality plots with tests. That's going to give you the Kolmogorov-Smirnov test and the Shapiro-Wilk test, and we'll just use those. So let's pull that up and see what it looks like. So that took about 2 minutes of my computer. So here is the case summary. We don't care about that. We're going down. We don't care about the descriptives. We do, but not in a test of normality. We're just going to scroll down to this box. So normally we use the Kolmogorov-Smirnov test, but 9 times out of 10, these two are going to agree, the Shapiro-Wilk and the other one. So again, if it's less than 0.05, it has violated the assumption of normality. And I'm scrolling down here, and it looks to me that most of them did, in fact, violate the assumption of normality. So that's a bad strike. That means we cannot use a t-test, but we're going to double check, and we're going to check the homogeneity variance by pretending to run a t-test. So we're going to go to Analyze, Compare Means, Independent Sample t-test, and we're going to put in all the scales. And the grouping variable is group. Define it. So we got 1 for the clergy, 2 for the non-clergy. Click OK. And again, we're just looking at the first row. The first column it's going to give us is the homogeneity variance test. We're not really going to use the t-test, even though the t-test and the Mann Whitney U-test probably has the same results, whether reject or not. But this is what we're going to look at, the Levine's test of variance. Again, if it's less than 0.05, it violated that assumption. So this one did. This one did. Most of these did not violate the assumption. So it looks like it violated normality, and a couple of them did violate the assumption of homogeneity variance. So it makes more sense just to use the Mann Whitney test for all of these, which is what we're going to do right now. So I'm going to show you a couple of ways to run that Mann Whitney. You're going to go to Analyze. You're going to go to Non-Parametric Tests. That's why you're using the Mann Whitney U test, is because the data, the DVs, violated normality, and a lot of them also violated the assumption of homogeneity variance. So if a parametric test violates the assumptions of the data, you switch to the non-parametric versions. So we're going to go to non-parametric independent samples, and I just click here, get the error message. Okay, the test fields are the actual scales. Bounce them all over there. Your group is your grouping variable. You hit run, you give it a minute, and you're going to get this long table that's going to run a Mann Whitney U test between each and every one of these guys. And it only took about 15 seconds on my computer, but here's the results right here. So Mann Whitney U says there's a difference between the TSI2 raw, trauma, self, etc., etc. So in other words, the orange colors means there's a significant difference between the groups. So you got a bunch of them going on in there. Now I'm going to show you a different way to do it to get all your test statistics, and I guess a lot of the professors want to see that as well. So you're going to go to Analyze, Non-Parametric Test. This time you're going to go to Legacy Dialogues, and you're going to use the old independent samples there. Same thing, put in all of your variables, or your scales, I'm sorry, and then put your grouper in there. Bam. Define the groups. You got your 1 for group clergy, you got your 2 for the non-clergy. Click continue, click OK. And it comes out like this. So these are your what we call your mean ranks and your sum of ranks. And a lot of the professors will want to see this in the report. Okay, so there's your mean ranks and sum of ranks. And then down here at the bottom, you have, okay, you can't see it. Hold on a second. Can you see it? No, hold on. Let me fix this screen. But here it is. So here's your actual Mann Whitney U-test. Well, I'm going to delete the Wilcoxon, but here's the Z-score test. And if these Z-scores are greater than 2 or less than -2, that means you got a significant difference between them. And it should agree with the color coding on the table of the Mann Whitney, whether you're going to reject. And this is it's a two-tailed assumption. If you don't know if there's a difference between these scores based on whether they're clergy or not, it would be a two-tail. But if you're assuming that the clergy members will have a higher rate or a lower rate, that's what we call directionality, that would become a one-tailed test. So that's easy. All you got to do is divide the two-tailed sig values by 2, and that gives you the one-tailed test. So I'm going to put all that stuff in there for you. But that is basically it. Okay, I'm going to go ahead and cut and paste this stuff into an Excel, clean it up for you, send it to you, and it should have everything that they're trying to get. All right, I hope this helps. MGZ out.